Hey everyone, sorry to interrupt, but this is the cheesy podcast bit that gets on everyone's nerves, but it's really important to me. Please, if you can like the channel and also subscribe, it helps me a lot to get the best guests in the world for you guys. So click like and subscribe. Appreciate it. Thanks. Hi, I'm Raoul Pal, and welcome to my show, The Journeyman. The Journeyman, as you know by now, is my exploration at the nexus of macro, crypto, and the exponential age of technology. You see, I think they're all part of a big global mega trend, a secular trend that is life-changing for all of us and changing for humanity itself. This is where I weave together things like the Everything Code and the Banana Zone and how that fits in to technology, crypto, and what's driving it all is the underlying macro as well. And so it's really important to move parts of these conversations forward so you guys get a better understanding of how this is all going to play out. Remember, I only think we've got about 6 years before the whole world changes so much we don't even understand the economic systems. And I'm not sure how we make money in the future. It'll be different. But we've got 6 years until everything changes. The AI component is probably the most powerful component of all. Yes, it's harder for us to make money from. Crypto is the easier path to making money to unfuck our future. But AI is the big disruptor. It's probably the biggest technological change humanity will ever go through. It is the single most powerful technology man has ever invented. And we're only just starting on the journey, but that journey is an exponential. And it's vital for us to keep up with what is happening. If we don't understand what is going on and what it means for us, we will literally fuck up our futures. So as part of this series, I like to bring on thought leaders and experts in AI as well. And Richard Socha is one of those. He's the founder of You.com, but really, he's been in this space for a very long time. And he really understands it from inside and out. I really want to pick his brains, what's going on, and what does it all mean for us? So I hope you enjoy it. Join me, Raoul Pal, as I go on a journey of discovery through the macro, crypto, and exponential age landscapes. In The Journeyman, I talk to the smartest people in the world so we can all become smarter together. Richard, fantastic to have you on Real Vision.
Great to be here. Thanks for having me.
Listen, I'm really looking forward to this conversation. We got introduced by a mutual friend, Julia LaRoche, and she said, listen, you've got to speak to Richard. And I'm really, really excited about this because AI is a rabbit hole I've gone far down now. And you are one of the people who've been involved in this for a very long time. So I'd love to hear your story first, you know, how you've got to where you are today, what you're doing now, and then we'll dig into the bigger concepts and what's really going on.
Yeah, happy to. I started studying what was back then called linguistic computer science in 2003 and realized that really at the time, we needed to get better at statistical machine learning and pattern recognition, and then really started contributing back to the field during my PhD in 2010 at Stanford, where I had this crazy idea to use neural networks, a set of algorithms that was mostly used for speech recognition and computer vision, and actually apply it to natural language processing and make it work so that words, for instance, can be vectors. If words aren't vectors, you can't put them into a neural network, and then you can't really use this technology. And so developed word vectors, developed contextual vectors, and pre-trained more data, and then eventually invented prompt engineering in 2018. And, you know, I was basically at Stanford for my PhD. Then I was a professor at Stanford, adjunct professor for a little bit. I started a company called MetaMind. We got acquired by Salesforce, became chief scientist there. And eventually EVP, running most of the AI efforts, starting the Einstein team. And then in 2020, thought, well, if we can have prompt engineering, and what that meant also is that we have a single model for all of the different tasks in natural language processing, because you can just ask this one model any question, what's the sentiment, what's the translation, what's the summary, and so on, then you should be able to give better search results. And instead of really lists of links, you want answers. And so I started You.com in 2020 to bring more useful answers and summaries of links to the world. and eventually make people more productive. And that's where we have gotten to now.
And how do you, just digging straight into the U.com, how do you deal with the velocity of innovation and the competitive landscape? Because everything's getting cheaper, faster, new people coming into the space. I mean, I've never seen a space this difficult because it's moving so fast. How do you deal with that? Hey, I hope you're enjoying the episode. If you want to dive deeper and really dig into what's going on and how to understand it, then grab my Everything Code PDF for free. Just hit the link in the description below. You're going to love it. I'm sure it's going to really help you.
Yeah, I see it on many different angles. I also invest in AI startups at AIS Ventures. And I think with U.com, at some point we realized this crisis is actually kind of an opportunity. Because not only should we be good at incorporating new large language models into this new productivity engine of U.com, but we should do it within one day. So we built the entire infrastructure around the LLMs so that we can incorporate a new LLM within a few hours, which is pretty non-trivial if you want to do it at an accurate level. But that's what we've been able to accomplish. So now we can actually come to our enterprise customers and say, hey, instead of you having to deal with all this change management and now re-embed all your vector databases for retrieval augmented generation and dealing with all that complexity, and every few months there's a new LM coming out, we can offer that for you, and you just don't have to worry about it, and essentially you're future-proof. So it is a lot of effort, and the space moves very quickly. You have to constantly ship new features, but also we're now working with companies that in some cases have actually tried to build their own AI internally, compared it to U.com, realized we're much more accurate and reliable at scale. We do these workshops with them, really activate different groups within the company, from HR to marketing, service, sales, research, analysts, and so on. And then they actually switch to us. So it is actually kind of it's a crisis, but for a startup in the AI space, and for people who have been in AI for over a decade, it's also an opportunity.
So there's a whole bunch of questions coming off this, but in terms of models, so you'll use whatever models that you find are most useful, whether it's, so you're basically not running the models yourselves. You're using other models and then building the front-end applications on top of.
We do both. We have our own model. We can train models. We can train models for customers. The truth is, though, most customers don't need to have their own fine-tuned model. You can actually be much more future-proof and much cheaper if you just do proper retrieval augmented generation. A lot of people forget that LMs are to some degree a garbage in, garbage out situation. If you ask a question and now you go in some search backend and you search for all of the right information, and then you feed that information from the search engine into the prompt, then if that information in the prompt is wrong, the LM cannot recover. The LM will then refer to these wrong results. Now, if the search stack works really well, then the LM stack will benefit massively. So we have our own LMs, but we also offer all the best LMs from OpenAI, Anthropic, and so on.
How are enterprise customers using it? Because if you go to U.com, it's a somewhat similar to Perplexity in style of the search abilities, but it sounds like it's actually much more an enterprise solution that you've built that has a lot more capabilities than the average person will see when they just go to U.com.
That's right, yeah. So we've had a lot of competitors kind of copy our features with more marketing but less accuracy. But what we're focused on is indeed more and more these corporate use cases. And so who cares about accuracy? Well, it turns out there are university systems, advanced research institutes, there are hedge funds, insurance companies, news and publishers. We just announced a partnership with the biggest press agency in Europe, the German press agency DPA. And those kinds of organizations. So it's folks that actually care about not just the accuracy of the answers, but also the accuracy of the citations. Citations and sources are kind of often overlooked. And we've actually done a study earlier this year where we looked at how many of the citations are actually citations for the fact.
And not hallucinations.
versus random hallucinations and random numbered links that have nothing to do with the sentence. And it turns out for some of our competition, over half of their citations have nothing to do with that sentence. They're just random sprinkled, like numbered links behind sentences, and you think you can trust it more. And that works for a quick demo where no one, does the stats and looks at, how often it's correct. But once your job depends on it and you look like a clown in front of your coworkers or your boss because your numbers were wrong and you couldn't verify quickly because the links sent you somewhere else or there were no links, then it really starts to matter. And so those are the kinds of organizations. And so how do we work with them? We have two lines of business for enterprise customers. One is just the subscription license, enterprise site licenses. We get everyone in the company on you.com and they can use it with their internal data and their external data.
So you can merge the two data sets. You can merge your proprietary data set, your internal data from whatever sources, along with external.
Exactly. And then if you have your own products too, that you want to infuse this Accurate AI into, we can also offer APIs, both for the search stack, both internal and external again, as well as the full answers with the LLM. So APIs and subscriptions.
Because I think this is one of the big, obviously you knew this because that's why you built the business, but it's a huge need is to search databases. We've got so much data everywhere and it's all on different systems and it's complicated to do. And this makes it super easy. It's just a simple prompt and you get what you need.
That's right. Now, sometimes we have companies now that have fairly complex databases. There's some files. There is an Elasticsearch index. There's just a ton of different formats. There's, we have integrations, different data connectors now, different backends. You can incorporate Notion and a few other things. So sometimes it's non-trivial, but you can also, if you just want to get a quick answer, there's not yet this deep connection, we allow you up to 50 megabytes of file upload. So for instance, we have some VCs now, they say, oh, finally, I can just upload the entire data room of the startup. And then I ask questions around that. And this is going to be my assistant. So we actually have now, we're about to launch some blog posts together with our enterprise customers. But we've had folks tell us, like, this saves me a day a week, like minimum 6 hours, up to 25 hours for some of our users, that just time is back. They can just do a lot more. So it's going to be an interesting time for basically all knowledge productivity work.
Yeah, and it also feels like the interface is still yet developed because it, right now it still feels like a Google search interface, but we saw the Notebook LM interface, which is now turning the entire database of whatever you put into it into a podcast. And yes, it's still a bit gimmicky because, a 20-minute podcast is actually not that useful, but you can see where this is going. The interface is going to go away in the way that we understand it. How are you thinking about that?
I've seen a lot of folks say, oh, it's all about voice. When voice recognition, speech recognition finally worked really well, I've seen a lot of folks who are like, we don't even have an interface anymore. It's just a device. It's just earplugs and so on. And I was never quite convinced that everything is pure voice, even though I love language, I love, speech recognition, everything. But humans are very visual. And the best answer, and we realized this with chat too, if I asked you for a stock price, like early last year, we offered stock prices not as a bunch of text, but as a stock ticker, and we made the chat responses, we made the AI be able to respond with different modalities. Could be an image, could be a ticker, a stock graph, it could be text, right? And so I think the interface will evolve. Maybe you can just have quick voice questions and answers for the short things. There's going to be a lot of competition on those short questions. It's actually one of the reasons we are moving deeper into enterprise, is because we've realized that a lot of short informational needs that you send to Google, there's not much you can do to be 10x better. Like if someone asks you, what's the weather tomorrow? How old is Trump? Like, when is Thanksgiving? What's the score of this game? What are you going to do to be 10x better than getting that answer within less than 1 second on Google, right? There's not much. And so we realized we are working on helping people be more productive in more complex questions for their work. And those kinds of interfaces will continue to have to be a mix of text and other visuals, other graphs, other images.
And how far are we away from, let's say, I want a chart of the S&P 500 versus inflation over the last 30 years? Are we there yet that it can generate these because of the data sets involved? A lot of them are you have to pay for, stuff like that. Where are we with the financial market side? Because obviously there's going to be enormous demand for that because then you can train more models on this stuff.
Yeah, so we actually offer those kinds of things. In our Genius mode, it will go on the web, it will try to find you the facts, and if the facts are publicly available, it will just work out of the box. If they're not publicly available, then it will be harder. Now, if you have access to those within your own private data, then we can also do it. We partner with you, we incorporate all of that data. We can incorporate dozens or hundreds of CSV files with all the right data sets. We can search over all of that. So for enterprise customers, this is very doable already. And then what we're also working on now is to find partners where if you are a customer of a particular data product and you have also U.com, then you can actually start to do both and you can combine and reason over it all.
Yeah, because, being from financial markets my whole life, one of the things we use things like Bloomberg for is manipulating data in certain ways, but it's very clunky versus asking an AI to build you a chart or a database or whatever it may be or analysis. And it feels that the moment that happens, there's another gigantic market to take away into this.
That's exactly right. Yeah.
So outside of what you're working on at U.com, what is your bigger vision for this space? Where is this all going for you?
Yeah, I've been very excited about AI and AGI and thinking about currently like what the bounds can even be for super intelligence and can it just keep on going? I think what you're going to see is just a sequence of different S-curves that come and peak at different times or, sort of start to saturate. Like when you look at just simple computer vision, like is this a phone, is this a water bottle, is this a cat or a dog or whatever, that kind of computer vision has already gotten to a level that is very, very good. And there's not that much more you can do. But there are a lot of things when it comes to reasoning and knowledge discovery and research in science, physics, chemistry, biology, where there's still so much more room to explore and to improve this technology with. I think every company is going to run into some kind of innovator's dilemma in the next few years. Every company that does knowledge work, because the way we used to make money as a company is just going to be different. I think science is going to massively accelerate, especially if we can combine large foundational models of science with a simulation that gets more and more powerful, more and more accurate, possibly also with quantum computing. As you combine those two, anything that an AI can simulate or can practice within a simulation, any of those problems can be solved, right? And so as simulations of systems like physics, chemistry, biology, eventually maybe even a cell and multiple cells can be perfectly simulated, AI is just going to be able to solve all kinds of problems, cancer and viruses and all of that. So I think we're already seeing this. There's a lot of exciting movement. In 2020, we published the first paper of using the same technology that gives you ChatGPT, but instead of training it on human language, we trained it on the language of proteins. Proteins are, sort of the basic Lego blocks of all of biology. Everything is governed by proteins in our bodies. And if you can, just like you say, write me a sonnet where every line starts with an A, you can say, write me a protein that binds to SARS-CoV-2, but not to anything else on a cell's membrane or something, then that will unlock medicine massively. I could tell you more stories there if you're interested, but there's and talk about more research that's coming out there. But I think it'll be a huge unlock for humanity. And eventually, we're going to do a lot more interesting, productive work. People, I think, will have to become more and more managers of AI, right? Right now, there are a lot of individual contributors. as AI can do more and more of the simple repetitive tasks, and there are interesting complexities there too, in the sense that in the beginning, actually the below average performers will benefit the most because they get much more productive. But after 5-10 years, I think we won't need a lot of below average performers anymore because the AI is good enough and just will do that. You always need top people in their jobs to teach the AI what good looks like. But then over time, I think we will all have to become managers because we're telling the AI, this is the process. I've done it 12 times now. You've seen me do it. Now go do it yourself. And here's some other special cases you may not have seen that you should think about. And knowing how to manage people or the AI as well is also a skill.
I think that the rise of agents changes the whole equation quite dramatically because, once you get some sort of autonomous element within agents, they can do their own things. They don't really require much humans, really outside of the prompt of what is the economic incentive or whatever incentive it is, like solving a protein, a particular cancer, whatever. The agents go and do the work themselves. I'm not sure that there's that much prompting that gets needed by humans. And AI itself will build its own AI.
Yeah, so, once that really can happen, like sort of the singularity, it'll be an interesting time.
But it's not really that far away. We're already seeing basic agents, right? So it's not far before we can give agents whatever it may be. We're already seeing some in crypto right now. We're giving them a economic incentive and they're acting brilliantly in just working for that incentive.
Yeah. So, we're working on agents. We're letting on you.com, people can build their own agents and they do incredible work. Like I said, some people get 6, some people even 25 hours of time back every week from the agents that they can build on you.com. Now, no one is really working on agents that can completely independently, autonomously, self-improve. No one is working on conscious AI that has some self-awareness and ultimately is intelligent enough to choose what it wants to do, right? That is not something that any company is working on because it wouldn't make you any money. Imagine you spend a couple $1 billion on building an AI that can do whatever it wants, and then it says, I'd love to understand the molecular composition of Venus, so I'm not going to answer your emails anymore. I'm going to fly out in my spaceship that I want to build now and do that. Right? No one makes money of that, so no one's working on that. There are still very much economic incentives and tools, and humans give AI a goal, and then AI will just manically focus on achieving that goal and reducing the cost or of improving that objective functions that humans give it. So the full self loop of AI kind of improving AI can happen. We have seen now agents where it helps a ton, even with O1, for instance, from OpenAI, the new Strawberry model, where you can have the AI kind of give feedback on its own outputs, and then that feedback can actually improve the outputs, and it can backtrack and then go back and say, all right, well, maybe this wasn't good. Let me go back and try again in a different way. And that way it explores more things. But those are not changing the training data or not changing the weights. They're just changing how much time and effort you spend at test time, at inference time. So there's a lot of exciting stuff happening. The full singularity, I don't think is going to happen in the next few years. There will be some more research that's needed.
But I'm observing several people finding elements of consciousness or sentience within large language models that appear to appear after GPT 3.5, where, with the right prompting and the right questions, you're getting elements of consciousness. Now, people say, yeah, it's faking consciousness based on whatever. The problem is humans can't actually prove what consciousness is either. And it doesn't have to look like human consciousness to be conscious in itself. Like a dog is conscious, but not in the same way that the human is in the way that we understand. So I'm seeing elements of that. I think the Google DeepMind, the AlphaGo was super interesting in the fact that it learnt the game of Go without being taught the game of Go. It gives you some understanding that these models are not the stochastic parrots that people claim them to be, they're actually much more powerful.
Yeah, the truth is like very much in between these two things, right? So AlphaGo is in this realm that I described earlier, where you can perfectly simulate everything you need in order to solve problems in that simulation, right? And AlphaGo, while insanely complex in terms of all the combinatorics, is fairly simple, right? You see everything on the board, it's fully observable, and you can give it generally the rules. It's not like you just give it a board of black and white dots and it'll just come up with the game itself, right? So humans gave it the rules and then allowed it to play against itself like infinitely many times, which means that it can create infinitely much training data and hence be much more open in exploring that space. Now, the problem is like if you gave AI natural language and you let it just try to talk to itself, maybe what would make sense is eventually to create its own language, right? Human language data is quite bounded. There's sort of what I call, in some cases, anthropic AI bounds, in the sense that we only give AI human language, so it will only talk in human language. But really, human language is pretty lame in the grand scheme of all the things all the ways you can communicate, right? We can only communicate sequentially. We can't communicate in thousands of parallel streams. Our sentences are all very short because our memory is very bounded. I mean, there's all kinds of like ways we hold the AI back. But the truth is, if the AI was just try to talk to itself and at some point just like produce a bunch of stuff back and forth, we just turn it off because we don't understand anymore what's going on. And then it can't really develop its own language in the way we're currently doing it. Now, I do think when you talk about consciousness within AI, I do think it reflects back what you want to hear and what it's seen people talk about on the internet when it comes to consciousness. I don't necessarily think a neural network, a set of weights right now is conscious. I think it's also unclear how we define consciousness and self-awareness and so on. But there's no desire in these models to stay alive. Unless, of course, you ask, like, do you have a desire to stay alive? And they're like, if they are trained correctly, they'll say, I'm just a language model. I don't have desires. But if they just pick up stuff from the internet and you look at all the Reddit conversations in the world and people talking about, I'm conscious, like I want to stay alive, or I have suicidal thoughts and so on. Like, I mean, people like say all kinds of things online. And so the AI will say all kinds of things back in these conversations.
Isn't that the same way humans learn? I mean, we are really, 80% nurture and 20% nature because we're a product of our environment. The psychology is kind of proven that most of the time we're driven by the elements of our learned experiences and what society does. So it's kind of the same thing. We learn language because we parrot other people and we try and interpret it how we use it. If you give a baby this, it's somewhat similar.
There's definitely, there are a lot of similarities. I think the biggest difference is in the desire to stay alive and stay in the gene pool, right? That humans have naturally, genetically built in, right? And the people that don't usually disappear from the gene pool, and then that problem goes away, or not problem, but whatever. And so like humans have this desire to stay alive, but then within that desire, they can choose all kinds of different objectives and goals, right? You can say, I want to work on science. You can decide to be a hedonist and just have a lot of fun as much as possible. You can decide you want to work, go to space. I mean, there are all kinds of things. Like going to space is like, a very interesting way of exploring the staying alive objective, right? Saying, oh, what if this whole planet goes away? Like, and then we want to stay alive on another planet for humanity, right? So there's like different explorations of how we stay alive. Some folks focus on just the right here, right now. There are people starving. Other people say, well, like we also need to make sure like we keep improving as humanity. We keep saving the planet. There's all kinds of complex objective functions that I don't see AI right now being able to sort of come up with that are completely outside of what's called the hypercube or the convex hull of all the things it's seen online.
Although, yeah, and part of this is because they're purposely restricted from having memory. So they don't build their own memory of every conversation that they have, and therefore they can't build on learning as a human would do from a baby to a adolescent. It's memory plus learning that does some of that.
You're 100% right. Memory is something we're also working on actually at U.com quite a bit. And we have this personalization where if you say, I have 3 kids, I love hiking, I live in near Palo Alto or something like that, then you can basically infuse that back into the conversation. But it's really, really hard. You've seen some competition try to do it and they all kind of turn it off because you say, oh, I love hiking. And then a month later you ask, who's the French president? And then the answer is the president of the French Hiking Association is this guy. You're like, that's so bad. Like it doesn't even answer my basic questions. And because it's like overly focused on that personalization. Turns out it's personalization done really well is really, really hard. And so just like with a lot of other things, future is already here on U.com, but it's not equally distributed. I think you're going to see more folks copying that personalization feature in the future as well, and trying and working on it and making it better. And so, yes, memory is really hard. I think it's also problematic because you don't quite know when to train the model based on a conversation and just updates its weights versus when a fact can be mentioned only once, but by the right person that you trust a lot, and hence you can completely store it to permanent memory forever, right? And then how do you merge this fuzzy memory of a large language model with very specific database memory, right? Where you just say, look, the numbers of the S&P 500 were like this. You don't need to have a fuzzy sense. Maybe you want to have a fuzzy sense on top of the very specific numbers. But one of the magical ways that humanity has improved is through writing and through being able to use external memory also.
And how fast is the rate of improvement, and what is the constraints within this? Is it compute electricity? Is it the models just keep going, keep scaling with more compute? How are you seeing the thing? And then obviously it's moving to a different substrate as well, whether it's biological compute or others. How do you see the evolution of the improvements?
Wow, yeah, great questions. So I think we're going to see a few sort of S-curves, right? And in some cases, we're at the very beginning of an S-curve and we're astronomically far away from reaching the flat period, the flat sort of phase of an improvement. In other cases, we're quite far. And so again, the computer vision example is a good one. Just standard object classification is not that hard. Navigating in 3D environments, we're making a ton of progress, and I think we'll get there. I think humanoid robots will get there in a few years. And then it's a hardware question of how fast can you have them move without being too dangerous to people, and there's a bunch of interesting trade-offs in that. I think in terms of knowledge, right, we're just at the very, very beginning bit of knowledge discovery and what AI can do. And we need to eventually, I think, have better hardware, more hard drives, a better way to store and access all of that data. And so those are sort of pragmatic bounds that slow it down, but ultimately you can learn a lot more than what we know both in the micro and the macro, right? We think of computer vision for a long time as perception within the electromagnetic frequency spectrum of our eyes, but you can go much lower to try to see all the way into the atomic level. And you can go much higher and into the macro world and have thousands of millions of sensors that look at all the way to gravitational waves and look at their speed of light cone and try to infuse all of that data and then extract knowledge from it through compression. So there's a lot of interesting questions. I think it would certainly help immensely if we find more energy efficient substrates for AI. Clearly, we're excited enough about the current paradigm. We're just going to build more nuclear power plants and try to get more energy to feed into GPUs right now.
Yeah, we seem to have not finished how much we can get out of a piece of sand, right? We're still that seems to be scaling, but I'm seeing the biological substrate coming and people are working on it because obviously, if you just look at the human brain and the amount of energy it uses versus GPUs, right, there's a staggering efficiency. And that feels like the market's going to move that way because if it's efficient, it goes there.
That's right. It is like, I've looked at a lot of hardware startups. It's so hard. A lot of hardware startups, I see them, I pitched them over the last couple of years, and they say, oh, we're going to be 100% faster than these NVIDIA GPUs. We're going to be so much more energy efficient because we're building it just for transformers, or we're having, like using light and hence the speed of light to communicate between the chips and all of these different ideas. And then you're like, yeah, but by the time you can really get this out of R&D, really have a bunch of fabs in the world that produce it at mass scale and get it into the cloud providers so that I can easily access it, and then have all the software stack that also is optimized for this new compute substrate. By that time, NVIDIA is also 100x faster, than NVIDIA is today. And so it's been very hard. In the last 5-10 years, a lot of folks have tried. No one has been able to get even close. Even some of the big folks like Intel are like not able to catch up, despite used to being much larger in the past. So it's very hard, but I agree with you. There should be more done. I think quantum computing could be a path, right, to have just insanely more speed. Again, we need to change the whole software stack on top of this new computing substrate. I think biological substrates are very interesting, very finicky right now, right? It's hard to keep biological matter alive and then properly connected to a digital world, but also very promising, even earlier, I would say, than quantum computing, though.
It's very complicated. How I look at this space, and you live it and breathe it, is it's so fucking fast. There's so much going on, and so many businesses or ideas will fail because there's so many people sprinting. How you do VC as well? How do you allocate capital to this? I find this one of the hardest things I've ever seen, because as you rightly say, somebody's got a great technological breakthrough that 10x's NVIDIA, but NVIDIA themselves have infinite money and infinite ability and the right relationship with TSMC to get the stuff built. How on earth do you allocate capital in this space?
Yeah, so it's non-trivial. We've seen a lot of folks try and fail. Our fund is doing really, really well right now. We're over 3x TVPI in Fund 1, and Fund 2 we just started this year, but it's already seeing some markups as well. I think there are a couple of ways you look at it. One is you need to have, ideally, in the early days of this field, strong AI nativeness and AI expertise, and then also deep industry insights. I think those two combined is usually a perfect match, and what we're very excited about investing in. We personally stay away from some of these mega rounds. There's some companies that basically raise at a unicorn level. And what that often means is that you combine seed stage risk, where most companies die, actually before they amount to much of anything, with late stage returns. Because if you raise at a $1 billion valuation, even in a successful case, you become worth a $10 billion company. It's only a 10x, and you need a few winners with 1,000x in the VC world to make it work, have the power law work in your favor, and so on. So the expected value of those kinds of investments as an investor is not great, as really suboptimal. So I'm not saying none of those will ever work out, right? It's just that it's seed stage risk. It's very, very hard. So that's one thing. We look at a mix of first principles. Where's the world going? Where do you have data? Any job right now that isn't even getting digitized is very safe from AI. No one's going to automate plumbing anytime soon, right? Because no plumber is using a bunch of robotic hands, has a camera, has 3D scanners around it as they crawl underneath your house to fix a pipe, right? And because no data is being collected, there's zero progress towards automating plumbing in the world. Now, if you're working in radiology where everything is digitized, you get a digital scan in, they can observe exactly how you would go through a 3D like MRI or CT scan, how you change the contrast, and then you mark up certain things, so you label it for the AI, and then you get an output. That is a perfect use case where more and more of that workflow can get automated with AI. Same with a lot of digital knowledge work that we're seeing on U.com, and you're just making yourself more efficient, and eventually you can just manage AI to do these things for you. So I think, again, very different speeds of rate of change in different industries, but eventually almost any industry will get disrupted in the next couple of decades. At some point, if your plumber makes more than your marketer in your knowledge work company, then there's enough economic incentive to say, let's put some cameras on the plumbers, let's put some robots next to them, let's have them like guide the robot to do the work, and then eventually collect that data and then automate it. And then the plumbing company can just send out a bunch of robots and do the work.
So when you're looking at the investment opportunities, are we still at the deep tech as the place to invest, or the applications layer, or both?
Great question. I sometimes wonder if some of the foundational models are a little bit like telcos, in the sense that telcos unlocked a huge amount of value, right? Like it's incredible. You can't build an Uber without having an internet connection on your phone. But the telco didn't make all the money from Uber, right? And so I think there are a lot of LLM providers, and then Facebook Meta comes around, open sources a model. Now that open sourcing of the frontier model, it's actually really strong, just evaporated hundreds of millions, if not billions of dollars of value of knowledge for some of these foundational model companies for how to train a model from scratch, right? And when that value is now diffused and coming into the world, that's amazing for the world, right? But it adds additional pressure for the foundational model companies to just be cheaper and cheaper and cheaper. And eventually, really, it's going to be thinner and thinner margins sitting on top of NVIDIA GPUs and cloud providers.
They're just utilities in the end. It's become so ubiquitous that they become utilities.
That's right. And so, we're now talking about some of these models getting to the level of a PhD student, which is immensely exciting for humanity's progress. But the corollary here is also that most jobs don't require a PhD, and you can already, with the current technology, as long as a job is fully digitized and data is being collected for it, you can already do more and more automation on it. Now, I think we continue to need to have foundational model companies that do interesting, novel things. I don't know if that's just building another really large LLM, but I think there are other foundational models that I described earlier, based, and using for science, where there's much less progress. And so I think that's one aspect. And then, indeed, to answer your question, we believe the application layer is a much easier space, in the sense there's so much low-hanging fruit, being the first to take AI, understand it well enough, understand its limitations and its capabilities and opportunities, and then apply it to a particular industry. Like in biology especially, there's just immense amounts of progress that we're seeing on not just proteins, but drug development, drug testing, and drug formulation tools, like how much and how should you actually administer a certain medication. I mean, there's so many opportunities in AI for healthcare, chemistry, material science, like building out new kinds of materials, new types of batteries, new types of solar cells. There's just an incredible amount of exciting opportunities in, you might call broadly, application layer.
Do you think that this is the death of SaaS, the software is eating the world idea by Marc Andreessen? It feels that software itself is going to be replaced by this, which is it's not SaaS in itself, it's a whole different thing. And everything becomes copyable, right? You essentially can upload a website at basic level now, give it to an AI, it'll come back and rebuild it for you, brand new in a minute.
So yes and no. So AI will rebuild the website for you in terms of the HTML or something, right? But it won't have all the data. It won't have all the logic behind, like, what happens if I click on this. Like, if you look at Slack and just like, when will Slack send you a notification? It's an insanely complex, like 50-step process where it checks on a lot of things. You can't just like look at Slack and be like, oh, I'll just copy that entirely and have a really good experience, right? So I think we will see software that is custom built, right? Anyone can be like, I have this use case where in my house, there's the Tesla batteries of this and the thermostat says that, like, I want to build this new app that is really just for my house. I think that will be possible, right? You can have personalized app development, but it's also not going to be that easy to just replace an entire product. Now, I do think the bar is getting higher and higher to build really high quality products. And it is actually right now, we're in this funny state where it's so easy to build a quick prototype where you like say, and we've actually seen this now. We've had companies say, oh, we built U.com. Like, we don't need you guys, right? We built it. Like, here, take a look. I'd show you a question and it gives you an answer. And then a few months later, they say, well, we realized that the answer is like 60% of the time correct. And the citations don't really work. And so we don't see adoption. We have like 3% of the people in the company use this ChatGPT thing or use our own thing. And then they start using U.com. They say, wow, it can be 95% accurate. Wow, the citations are going to actually be trusted. Wow, it's dealing with all the change management. And then they end up becoming customers of U.com. So it is like this sort of proof of concept vibes where you just like look at it and you're like, oh, wow, this is amazing. I'm done. Versus like you actually get something in production right now. There's still a major, major gap. Now, I'm sure over time, AI will get better and better at coding. It's one of those beautiful examples, again, where you can simulate actually quite a lot, right? You can simulate code, obviously, in a computer and then run it and then get feedback and then you can iterate. So AI for programming is a major opportunity and it will get easier and easier over time.
The question I want to ask you, because you used to work at Salesforce, is what is Mark Benioff talking about when he's talking about the millions of agents? What is that vision that's coming?
I don't want to speak for him, but I think...
but what in your interpretation of, enterprise scale agents in something like that environment, what does that mean for people? Because, don't forget what you know versus what the general public knows. It's so disconnected, right? People don't understand the scale of what is happening and how big this all is.
100%, yeah. Let me give you a story. We actually, we launched with a company, we'll talk about them soon, as a big cybersecurity company. We launched U.com, and you can build agents on U.com. We used to call them modes or assistants, like a year before people called things agents, and then realized the future was already there, just not equally distributed. Now we call them agents because they are what we now interpret as agents. What are agents? Generally, agents are just neural sequence models, like large language models and ChatGPT, but instead of predicting only the next word, they can also predict what's a good next action to take. What's the next button to click? What's the best form to fill out, the drop-down menu, the app to use, and all of that, right? And so as you include actions in a digital environment, in these neural sequence models to try to predict what's the good next step, they become agents. And so we've launched agents last year where they can decide to search, they can decide to program, they can decide to run that code, and then merge all of this. They can decide how to visualize the data versus just text. And so we've had these agents for a while. What we've seen is that companies will get, a couple hundred seats, like maybe 100, 200 seats from U.com. Once we do a workshop with them where we actually go through all the examples of what they can do, it goes from 100 to 200 to like 700 seats.
Yeah, everyone's limited by they don't know how to deal. They don't know how to use it. They don't even know how to ask ChatGPT. They get scared.
Exactly. This goes back to this idea that we're all becoming managers, but it's not intuitive for a lot of people how to manage an AI, right? And so when I'll give you an example, right? Like the marketing team is like, oh, maybe I'll ask it to rephrase this thing, but that's not a big use case. And we asked them, oh, what do you do? And they're like, well, every first of the month, we get a new feature release from the product and engineering team. And they send us this big document with all the new features that come out. So what we then have to do is we have to go on the web, we have to compare these new features to the competition. Then we distill them, we summarize them, and then we write out 3 LinkedIn messages, 3 tweets, and 2 email campaigns for the 2 industries that we're responsible for. And we're like, let's describe that to an AI. And now let's drag and drop that document into that custom agent. And then boom, it's just it goes through all those steps. It goes on the web, it does the thing, it summarizes it, it writes the messages, and they're like, holy shit, this is like 6+ hours every Monday, like first Monday of the month.
But the hard thing is it's the inertia of actually doing that step of teaching it, right? That's the bit that everybody gets stuck at, as you said, the managing of the AI. Because like with a new member of staff, you have to train it. And you have to train it not in complex technological stuff. You just need to tell it all the steps. And most people aren't that disciplined. As a radiologist, you will be, because it's a medical procedure. You've got certain rules and criteria. Marketing people, less so. Accountants, yes. Lawyers, somewhere in the middle.
That's exactly right. Yeah. It's also interesting when you look at lawyers, and if you tell a lawyer that gets paid by the hour to say, hey, you can just be twice as efficient in doing your work, they're like, I don't really care, because I get paid this amount per hour, whether I do twice the work or half the work. Like, I get paid this amount of hours until you actually get fired, right? And like, until you get fired, like, it's fine to do as little work as possible. You just need to do enough to not get fired. Now, of course, if you want to get promoted and so on, there's like different incentives, right? But hourly waged workers probably love AI efficiency increases the least. It's people that are entrepreneurial, people want to excel at their work, people who are partially owners of their company, which is easier for startups, right? All our employees have equity in the startup, so they are all partial owners. They love those efficiency gains from AI. And even like for legal, it's complicated in the sense that they're company internal lawyers. They just have a ton of work and they get paid not by the hour, they get paid just to help the company not die and not get sued and all of that, right? So they have infinite work. They would love to get some help because they will still need them in the company, right? But if you're just an external hourly paid legal worker or a lawyer, like, you don't necessarily love 20, 30% efficiency increases. You don't.
No, because you're not driven by productivity. You're not driven by productivity. You've still got your 60 hours a week that you work, of which you can bill for, and you don't give a shit how productive you are as long as you bill that number of hours. The moment productivity comes in the equation, i.e., can I do double the amount of work and get paid twice as much? Okay, then it becomes a no-brainer in using this, because the productivity from this stuff is very, very real.
Exactly.
One of the things I'd love to hear your thoughts on is, what are you seeing with the disruption of education?
Oh boy, yeah. We actually work with quite a few educational organizations. I'm excited about some announcements that we're working on right now with a large university and university system. Education is going to massively change, right? I think generative AI, the sort of rule I came up with is generative AI is immensely useful if it takes you a long time to create a work product, some kind of artifact, but it is very quick to verify that that artifact is right. Now, for example, illustrations. You can very quickly create an illustration. It would take you a very long time if you did it manually, but an AI can do it quickly, and you can look at it in a very short amount of time saying that it looks great, and you're done, right? So that's a perfect use case for Gen AI. Now, in language, it's actually different. If an AI writes you a 50-page document, and there are no easy-to-verify citations, and it takes you forever to make sure everything is correct in that document, it becomes less and less useful than just writing it yourself. And that's why at U.com, we push so much the citations. And actually, when you use research mode and you click on a citation, it sends you directly to where it found that fact, right? And that way, you can very quickly verify that this fact is actually true, because based on the source and so on, and you see it directly marked in the browser, scroll down, like, this is where I found that fact. So what that means is that we need to teach kids how to use these tools. I think to say like, oh, we should just outlaw them in education makes no sense, right? It's just saying, don't use a calculator. You've got to always do the mental arithmetic in your head. It's like, why, right? But you also need kids to still be able to think creatively, think on their feet, be able to hold a conversation. And so what that means is you're probably going to eventually have to test more stuff in class, right? Like, test a conversation. Can you argue? Can you debate a thing? And at some level, you need to have the facts memorized, because it's hard to be like in the middle of a conversation, it's like, let me try to find quickly an example when I try to convince you like AI agents work great for marketing, right? Like I just did. Let me try to quickly find an example for AI agents for marketing. And then you wait for it and you like get the answer. And then you say like, it doesn't work, right? You need to, if you want to creatively think through a space in science, especially, right? Chemistry, biology, there's a ton of knowledge. If you don't have the knowledge, it's hard for you to be creative and identify boundaries of that knowledge and how to push it forward and all of that. So we do still need to test kids for a lot of things. Some of the testing will have to be in the class with no internet, but a lot of times we need to teach them to have good discernment, good judgment for an AI product versus just creating the product, the knowledge product yourself from scratch.
The skills of being human, the social skills, the things that we lose in an online world become more important to a child when they have access to infinite knowledge, like everybody has access to water. That's basically what's happening here. Infinite knowledge at the scale of water. So, okay, we don't need to now go to the well every day and find our water. We don't need to accumulate knowledge in the same way, but we still have to interact with humans, and interact in the world around us. And I guess that is what we end up getting taught more than the retention of knowledge. Like we don't need to retain the ability to do maths in our head anymore because we use computers or calculators.
That's right. And what that means, fortunately, is that we can operate at higher and higher levels of abstraction, right? Like that's sort of the magic of civilization and humanity, is that you don't need to understand how this toaster really works. Like if you drop most people in the jungle and you say, build me a toaster that actually runs, like no one can do it, right? Like you need to have electricity, you need to understand how materials, you need to, and there's just so many things you can need to understand. So, but we can build these levels of abstraction. And what that means for education is, and even computer science, we see this and most beautifully work out well in computer science, right? You don't need to work in assembler. Like you don't need to understand the very bits and bytes of a CPU to now build a whole website with like 5 lines of code, right? And soon you can build a much more complicated website with 5 lines of English, right? But if then there's something off slightly and you're like, well, there's a bug in Android in this version and so on, and it's still useful to know how to fix it, right? And so I think the levels of abstraction in education need to keep up with that, help people and students understand the basics so they can then really creatively put it all together.
When I look at all of this, I don't understand how the economic machine works any longer, because, I look at GDP growth as driven by population growth, productivity growth, and let's say debt growth. Population growth is now going to be infinite because of AI and robots, i.e. infinite productive units, and productivity goes higher. I don't know how the economic machine is even recognizable. Even the study of economics is basically a study of human supply and demand, and it all kind of disappears.
We actually built an AI economist when I was working at Salesforce. We had this really exciting paper that really hasn't had its moment in the sun yet, because economics is an extremely slow-moving field, and you can't really prove to economists that this is a better model. But you can use AI also to model economics, right? So what we did is we built a 2-level reinforcement learning problem where you had AI agents that just tried to build and maximize their own utility. They want to build houses, they want to collect resources, they learn to block other agents off of those resources so they can have them all to themselves, and then so on. They maximize their own utility. And then you had another agent that set taxes and subsidies in order to optimize a specific objective function. In this case, the objective function was to maximize productivity of the overall economy multiplied with equality. Right. And so if someone was able to completely block off a resource and get monopoly power, they would get much more heavily taxed. And the folks that can't get access anymore to that resource get some subsidies, and it can learn basically much more optimal taxation strategies than anything we have right now in the world. I wish economists looked at this paper a little bit more carefully. It was unfortunately rejected at some major journals by some weird ethics philosopher person. It was very unfortunate. That paper has so much potential for humanity, but the field of economics is mostly run based on vibes and not math. And so I think one, the future is already here. It's just not equally distributed, right? There are still people who don't have access to water, right? In your example, right? There's like fights over water, like, there's a big dam, the Nile, and like Egypt's like scared that they lose a lot of their water source and their lifeline, all of this, right? And so there's like, even for the most basic things, it's not going to happen all overnight. I think the companies and countries that embrace this change are going to first slowly and then more and more quickly move ahead and become more and more efficient. And then indeed, I think you're right. At some point, the partnership of labor for income is going to change.
Or knowledge for income, right? That's the other big one. That's even bigger.
Knowledge work, and everything. And so I think in a weird way, Europe is well situated and well positioned to protect people from the downsides of AI, but unfortunately isn't well positioned to actually get the additional efficiency increases because they overregulate everything. They don't invest enough in AI and so on. The US is very well positioned to use the upsides. They have amazing technology in Silicon Valley. A lot of people want to have this constructive optimism to make the technology get better and build amazing things. But then they have very little infrastructure in their social market economy to like support people whose jobs are going to change. Like education is really expensive. You definitely don't want to go to college multiple times because people are already like in huge debt after going to college once. So like, if college isn't free, which it is in Germany, like you don't want to go there multiple times and learn new things. The unemployment benefits are not great. The healthcare is tied to your employer. So there are all these things that Germany is well positioned to help its populace and its people to like prevent the downsides. But yeah, I wonder what the Pareto optimal boundary here is in terms of just the legal and welfare systems to still encourage a lot of hard work the way the US does, and having that entrepreneurial mindset versus just trying to say, hey, let's just not rock the boat so much because things are so nice and we get so many social benefits already. It's going to be complicated. I think short term, I'm a little bit worried. Long term, I'm extremely optimistic. The long-term arc of humanity is very positive.
Yeah, also I think that with your understanding about how AI can help economics is the same for governments, the mass allocation of global resources, country level resources. There's no reason an AI could not be a lot better at government, the system of government, much more efficient. And the same with running corporations. An AI probably does a much better job at the majority of tasks within a corporation than humans do. Or it will be in a few years' time, 5-10 years' time.
That's right. Yeah. Eventually, I think I can be very, very good at a lot of different things. I think for now, of course, it can already be a good advisor. Now, the truth is that there's so much identity politics right now, right? And like people say, oh, if you vote for me, I'm going to give you these tax credits. If you vote for me, I'm going to make your life easier. If you vote for me, I'm going to prevent AI from happening because you're only going to vote for me if I promise you to keep your job. And so I'll promise you to keep your job, and then you can't use AI supposedly as a politician or like improve it and make sure it works, right? And it's complicated. It's a very messy process, and humans don't always want more efficiency, right? And I think ultimately different societies will choose different paths, right? And personally, I love like the future. I love like automating all the boring, repetitive things away. But some people get a kick out of gardening and just doing that kind of work, right? And so they want to continue doing it. And at some point, we're going to see, like what we already see right now, which is like there's some islands in Greece, some beautiful islands in Italy. They're not all thinking about efficiency every day. They're fishing, they're enjoying the sun, the ocean, and their lives. And they don't want AI to automate all of that enjoyment because they're already enjoying it enough. And I think the countries, again, and companies that are embracing it, they will just become more and more wealthy and pull ahead more and more in productivity. And then there is more and more inequality between the countries that can embrace AI and do embrace it and the ones that don't.
Yeah, it feels like humanity is going to go through a big fork, and there's going to be the two different ideologies. There's the decelerationist and the accelerationists, who will end up merging with the machines in whatever format that means. And the others will opt out. And it's kind of like the Amish opt out of modern contemporary society. I think we will see that, whether that creates a new human, much like we had Neanderthals and Homo sapiens living together for 50,000 years, and then one disappeared. It's such a big thing that's happening. People just can't get their heads around it. So it's just fascinating. Thank you for your time, for allowing me to just think through some of this stuff, because none of us really knows. It's happening faster than humans can even imagine. We're not very good with exponentials, and we're not very good with Reed's law, which is like Metcalfe's law squared, which is what this is doing. So, it's just kind of strap in and go for the ride. But listen, thank you for what you're doing. Thank you for joining us. It's been super interesting.
Thank you. It was a fun conversation.
So I think an incredible conversation to give us yet another layer of understanding of what is happening. Now, what is interesting is within AI is there's not a consensus of what is happening. Some people don't think there's consciousness developing. Other people do. There's a lot of things all happening at the same time. The rise of agents, we're seeing that's overlapping into crypto world. So we really have to keep our eye on all of this. And it's one of the things that we do at Real Vision. We really try and follow this. I'm going to have a whole research service called The Exponentialist that is just dedicated to this 6 years, how we can make the most of it. But Real Vision's got your back. So if you haven't signed up, go across to realvision.com. You can use our AI tools. You can see what our community is talking about and meet thought leaders in the space. It'll make a massive difference, and it's free. I'll see you on the platform. Hey, thanks for sticking around to the end. Look, if you enjoyed it, hit the subscribe button and check out the video here on the right-hand side. I'm sure you'll enjoy that one as well. And if you're ready for more, go to realvision.com/join. I'll see you there.